ask question number 14 for chapter 14. So in this question, they actually give you a graph of P against V. Okay, notice that the unit is in Pascal and M cubed, so both of this is in SI unit. Okay, the question wanted to find the work done for the process AB and process BC. And they want to find the change in internal energy for process AB and BC. Maybe we can start with question number A first. Okay, so if you want to find the work done for the process AB, so you know that process AB, you have a constant pressure. So for a constant pressure, you can calculate work, which is equals to P delta V. Okay, V here represent V final minus V initial, so it will be VB minus VA. So I can substitute the numbers now. The pressure is 3, don't forget the prefix over there. Multiply with VB minus VA, which is 0.04 minus 0.02. And if you press your calculator, you should get 6,000 joule. Okay. So if let's say you get a negative value over here, just leave the negative value as it is. Sorry. So and then they ask you to find for process BC. Here you have a constant volume. So using the same formula, WBC P delta V, since delta V equals to 0, volume is constant. So that means over here becomes 0 joule. Okay, so that one for question A. For question B, you want to find the change in internal energy for process AB and process BC. So using the first law of thermodynamics, you can use the equation Q equals to work plus delta U. Okay. For process AB, because they want to calculate separately, so we have to calculate separately. For process AB, the Q is actually given over here. If you read carefully, 8 kilojoule heat is supplied to gas in process AB. So being supplied to the gas, that means Q is positive, transfer into the system. I can substitute inside 3,000, sorry, should be 8 times 10 to the power of 3 equals to the work done that we get from the previous calculation, 6,000. Again, if you get negative over here and over here, just substitute the negative value. Over here, both of this is positive. So this one is 8,000 minus 6,000, which is 2,000 joule. Okay. The last part, maybe I can write it over here. Let's try to divide this part a little bit. Okay. For BC, the Q is given as well. In the process of BC, 4 kilojoule of heat is dissipated. So that means the Q is equal to negative 4 kilojoule. So because energy is scalar quantity, you need to determine whether it is positive or negative yourself lah. And you just have to carry the sign convention. Again, using the same formula here. Okay, if I substitute Q as negative 4 times 10 to the power of 3 equals to 0 from up here plus delta U. That means my delta U is equals to negative 4,000 ataupun negative 4 times 10 to the power of 3 lah. So, if you guys still remember, delta U is actually dependence on the temperature. So if the delta U is positive, that means the temperature increase. Delta U negative, temperature decrease. Over here it doesn't ask, so you can leave it as it is. Okay, so that's it for question number 14. Okay, moving on to the last question, which is question number 15. A mass of 5.6 gram nitrogen gas occupies a volume. So you can read on the question here. Okay, the first thing that you can do is that you can take out all the important information. So here the mass is given, so I can write it over here. Mass is equals to 5.6 gram, occupies a volume and pressure and temperature. Okay, so this one, if you read the question, you can see that actually there's a change in volume and temperature with a constant pressure. So this one is indicates that we have a constant pressure. So maybe you can write the pressure first. P equals to 1 times 10 to the power of 5 Pascal, and then you can write separately initial and final condition. So initial condition I put as V1 equals to 4.6 times 10 to the power of 3 centimeter cube. Final condition V2 is the one that we have to find. This one is not given. And then temperature 1 is equals to 280, and then temperature 2 is equals to 281. Okay, and then if you guys still remember our triangle too, the one that we always use. Okay, P, V and T. Over here when the P is constant, so we have VT over VT. So if you use equation, so from V over T equals to V over T, obviously this one will be my initial and this one will be my final condition. Okay, and then I can find the V2 first, because the question actually want me to find the change in volume. So the question actually want you to find delta V. So first thing, you find the V2, and then V2 minus V1 is delta V, which is equals to, let's write it over here. Okay, so this one is for question A. So I can write straight away my V2 is actually equals to V1 over T1, 4.6 times 10 to the power of 3, 280 multiply with T2, which is 281. Okay, you should get V2 equals to 4616.43. Okay, make sure you use the same unit as your V1, which is in centimeter cube. Now your delta V become V2 minus V1, which is equal to 4616.43 My V1 just now is 4.6 times 10 to the power of 3. Delta V that I got here is actually equals to 16.43 centimeter cube. So I use everything in centimeter cube for now. So final answer here will be in centimeter cube. So that's that one for question A. For question B, they want to find the work done by the gas. So B, you know that work done is equals to P delta V. This one is for constant pressure. So if you, the only difference formula that you need to use is when we use isothermal process. So isothermal process is the formula that we have learned, and this one is simple formula. So work equals to pressure here is constant 1 times 10 to the power of 5 Pascal multiplied with delta V that we calculate just now, 16.43. But since we want to write work, which is final answer would be in joule, so that means I have to change everything to SI unit. So the pressure is already in SI unit. The centimeter cube I have to multiply with 10 negative 6. So negative 6 because centimeter to meter negative 2, and then multiply by 3 because that one is cube. So now I should get 0. Oops, I think I calculate. Okay, so this one is not 5. This one is 5, not 3. Okay, so I just have to press my calculator again. 1.64. And it will be in joule. Okay, and then for the last question, question C. Okay, they want to find the thermal energy required when the gas is heated at constant pressure. Okay, that one is the keyword for Q. So if you use first law of thermodynamics, where the Q is actually equals to delta U plus work. Okay, since you already found the work up here, so you don't have to calculate more. You can use this value. Again, if you have a negative, you have to substitute negative inside here lah. And then for delta U, you have to find it first. Okay, to find delta U, you can use the formula F over 2, because you are given mass and molar mass, so you can find number of mole first. So I can use N R T. Okay, before I forget, since this one is delta U, so I should use delta T. Okay, if you're talking about nitrogen gas, so F is equals to 5, because this one is basically diatomic molecules. So delta U is equals to 5 over 2. Numbers of mole, actually you can calculate using mass over molar mass. So it should be 5.6 is the mass given. Molar mass is equals to 28.014. R constant is 8.31. Delta T is actually 281 minus 280. So that one is 1. I'm just going to write this one a little bit higher over here. So F 4 and n2 is equals to 5. Okay, and then this one I can write n numbers of mole mass per molar mass. Okay, make sure that the unit that you use is the same for mass and molar mass. Okay, here molar mass is gram per mole. Okay, down here is gram per mole. Up here should be in gram as well, so that you have mole. And so now if you press a calculator, get 4.15. Okay, this one is in joule. Now if I want to find Q, which is equals to delta U plus work, so it would be 4.15 plus 1.64. Again, for these two values, if you have a negative value, you have to bring the negative value inside here. So in this case, both of these positive. Final answer will be 5.79 joule. So that's about it for this tutorial. Thank you.